This video is on solving by the square root property. We've probably seen this before. You've probably seen the square root property in action. We're going to do it through some examples. And the first one I'll look at, if I said to solve x squared equals 25, for example, we can solve this by the square root property because we have the variable piece that's a perfect square and the other side's a constant. So when I say solve by the square root property, what I'm really saying is we're going to take the square root of each side. Taking the square root of the x squared just gives us x, and that's why we're doing it, because, you know, the x being to the second power, when you take the square root of it, you know, the 2 is the power divided by the 2 of the index would be just giving us x to the first power. So, you know, if I took the square root of each side of this, when I write a square root in a problem, remember, I should be writing plus or minus in front to get the positive or negative number that'll make this true. So the square root of x squared just gives me x. When I write the square root, I write plus or minus. Plus or minus the square root of 25. In this case, that answer would be 5. So x equals plus or minus 5, which is really two answers, right? This is x equals negative 5 and positive 5. You could also write it in the set notation, you know, negative 5 and 5. Curly braces indicating it's a set. Now, if the square root of 25 wasn't a perfect square on the side, you still could use square root property. You would just have to simplify like we normally do for square roots. But the square root property allows us to solve equations that have, you know, a term that's just a perfect square and the rest of it being constant. You know, typically you'll see it with just a single variable, but you could have, you know, an expression inside of this being squared, and we'll see that in a little bit. Let's say I was to solve a few more. If I said to solve this one here, if I said x squared minus 9 equals 0. Now, something to point out is that you could always solve these by factoring, but it saves us time if we try to solve it by the square root property. Here I've got, you know, a variable squared, and here I've got just a constant. So the easiest way to solve this, you know, is to get the variable part by itself and the constant to the opposite side. So here I'll add 9 to each side, and I get x squared equals a positive 9. And then now that I have the perfect square isolated, I can take the square root of each side. When I take the square root, remember, I have to write plus or minus when I take the square root. So the square root of x squared just gives me x. It's equal to plus or minus the square root of 9. Does that simplify? Well, yes, it simplifies to 3. How many answers do we have? Well, it's two answers, right? It's negative 3 and positive 3. All right, so that's two answers when x equals plus or minus 3. Right? Negative 3 makes this true, and positive 3 also makes this true. That's what this really says. Same thing up here, right? X squared equals 25. Well, x could be either negative 5 squared give me a positive 25, or positive 5 squared give me a 25. And that's why we have two answers. Suppose I had this one here, t squared plus 3 equals 27. Again, let's try to isolate that perfect square. Now remember, if there's another t in here, if this was like t squared plus, you know, 4t plus some other number equals 27, then you have to solve by factoring, or at least another method that we might learn later. But you can't use square root property unless it's only the one piece that has the variable in it and everything else is constant, right? So the piece that's squared has to have the variable and everything else is constant. So to isolate the squared piece, I'm going to subtract 3 from each side. All right, so we got t squared equals 27 minus 3 is 24. And then taking the square root of each side, because now I've isolated the perfect square, I'm going to take the square root. When I take the square root, I write plus or minus. I end up with t equals, and it's plus or minus, now the square root of 24. I'll write a square root of 24 right now. It's not a perfect square, so you can't evaluate it immediately like the last two examples. But what's important to know is that, you know, you could simplify it, and we should simplify it if you can. Now, it doesn't mean use a calculator and give me a decimal answer. I still want the exact value. The plus or minus stays in front. The square root of 24, remember, you want to split as the highest perfect square factor and the non-perfect square factor, each under the square root. The highest perfect square factor of 24 is 4. The non-perfect square factor, 4 times what gives me 24, would be 6. And then we're going to evaluate this. We end up with t equals plus or minus the square root of 4, which is 2, and then the square root of 6. The non-perfect piece stays the same, so t equals plus or minus 2 square root of 6. Don't move this plus or minus. It's not in between here. The plus or minus is still in front. So this is how many answers? Well, it's two answers, right? It's negative 2 square root 6 and positive 2 square root 6. So two answers here, and that's okay, right? You can get two answers. I'm writing it in the set notation. If I don't ask for it specifically, you could leave it as t equals plus or minus 2 square root of 6. But I don't want to see a decimal approximation. I want to see the exact answer unless we specifically ask for a decimal. Let's just take a look at a few more. If I had x squared plus 11 equals 0. So again, we have a perfect square that has the variable and then a constant, no other terms. If you have other terms in here, you can't do this, right? It has to just be a perfect square and then the perfect square variable and the constant. So we're going to isolate the perfect square, so we're going to subtract 11 from each side. I end up with x squared equals 0 minus 11 is negative 11. Don't lose the negative sign. And then you still want to use square root property because now we've isolated the x squared and we have no variables on the other side. Remember, this only works if you have the variables with the piece that's being square and everything else on the other side. Taking the square root of each side, remember when you take the square root, you write plus or minus. So we have x equals plus or minus the square root of negative 11. And we want to simplify that if we can. We have x equals, now square root of negative 11 is not a perfect square. We have the plus or minus still in front. The square root of a negative number, though, remember that means you can factor out an I. Remember our imaginary constant is equal to the square root of negative 1, so you can take the I out to the front. And then square root of 11 would be what's left. So it's plus or minus I square root of 11. The square root of 11 doesn't have any perfect square factors other than 1. So this is our answer. And there's two answers, right? The plus or minus indicates two answers. We have negative I square root of 11. And I square root of 11. You can write it as two answers like that, or with the plus or minus I square root of 11 in front is fine. Just make sure you understand that it is two answers here, right? There's two answers that make this true, in other words. Let's take a look at just a few more. If I said I had this one here, if I said I had a minus 5 the quantity squared equals 32. Now to solve this, you might think of expanding the a minus 5 squared and making it a minus 5 times a minus 5 and then foiling it and then solving. You could do that. It would work. But the key to this is recognizing that I have the piece with the variable in it as a perfect square and this the constant is all that's left over. So the easier way to solve this is to take the square root right away. Now, if you aren't watching this video, right, if someone was to not watch this video, what you've learned in the past would be to expand it, and that would still work. But if I say solve using the square root property, I want you to use the square root property. So in this case, we're going to solve these with the square root property. I'll take the square root of each side because I have isolated my perfect square, and I have a constant on the other side. Remember, when you take the square root, you write plus or minus in front. So we've got the square root of a minus 5 squared is just a minus 5. It's equal to plus or minus in front the square root of 32. Now we'll simplify that in a moment. Let's just make sure we've got that part down. Now I'm going to simplify the square root first, then I'll move this the constant over to the other side. You don't have to, you can move it now, but it's easier probably to do this first. So we have a minus 5 equals plus or minus the square root of 32. Well, what's the square root of 32? Well, the perfect square factor, the highest perfect square factor of 32 is 16. The non-perfect square factor that goes with it is 2. 16 times 2 gives you 32. And so we're left with a minus 5 equals, keep plus or minus in front here, the square root of 16. Now you evaluate it to 4. The square root of 2 stays that. And then lastly, now you want to isolate a. Remember, the goal is to solve for a when we say solve here. So I'm going to add 5 to each side. And we end up with a equals. Now when you combine this, 5 plus or minus 4 square root of 2, the 5 plus or minus 4 square root of 2, you're just adding it together like that. With, you know, the 5 and the 4 square root of 2 are not like radicals. You can't combine them. So this is two answers as it is. The 5 plus or minus 4, you cannot combine those. Sometimes people do that by mistake. Because of the radical 2 here, these aren't like terms. But really it's two answers. Remember this. It's 5 plus 4 radical 2, and it's 5 minus 4 radical 2. Again, you can't combine those, but it is two answers. So, you know, you could write your solution as this, or you could write them individually, or in the set notation, 5 plus 4 square root of 2 5 minus 4 square root of 2. It doesn't matter which of them you write first in a set. But having to understand these are the exact answers, right? These are the exact answers that would make this true. And let's just take a look at one more here. If I said to solve this one, if I had t plus 4, the quantity squared, plus 27 equals 0. That's a little different, similar to the last problem, but you know, I don't have the constant on one side, but I have a perfect square term that has a variable in it, and then the rest of it is constant. Now, remember, if there was any other variables outside of this perfect square term, you couldn't do this method. But since I do have this perfect square term, if you isolate the perfect square first, then you're able to use square root property. So I'm going to isolate the perfect square by subtracting 27 from each side. And I end up with t plus 4, the quantity squared, equals 0 minus 27 is negative 27. And then now that I've isolated this perfect square here and the constant is on the other side, now I'm able to take the square root of each side. Remember, you only can do this if there are no variables present on the other side. So when we take the square root, you're writing plus or minus. So we end up with t plus 4, because the square root of the perfect square just gives me the argument on the inside, t plus 4, equals plus or minus the square root of negative 27. Let's simplify the square root first, then we'll isolate t. So I have t plus 4 equals plus or minus. The square root of a negative automatically tells me I know I'm going to take out a factor of I. The square root of 27 is not a perfect square, but does it have a perfect square factor other than 1? Well, it does. The highest perfect square factor other than 1 is 9 times 3 would give me 27. And then we're going to simplify this. T plus 4 equals plus or minus I. Square root of 9, well, square root of 9 is 3, so it's 3 times I is 3i. Typically we write it like that. And then square root of 3 comes along. And now remember, the goal is to solve for t. So now we will subtract 4 from each side. End up with t equals, this is negative 4 plus or minus 3i radical 3. Remember, these don't combine. They're not like radicals. Even this is an imaginary piece. This doesn't. You can't combine them. So this is two answers. Make sure you understand that. This is two answers here. All right, it's negative 4 minus 3i radical 3. And negative 4 plus 3i radical 3. And those are the two answers. Got smudged a little bit. But the point being is that, you know, when you use the square root property, you'll get two answers because of plus or minus. But don't forget all the things we've learned in the past about simplifying square roots. It looks like it's coming up quite a bit. Don't forget, if you're taking the square root of a negative, you have imaginary numbers. If you write the square root in the problem, you're having plus or minus. That's giving you the two answers. Simplify the square roots as much as possible. But these are the exact values that would make this true. So this is important to know going forward in math. You know, as we continue in this section, you might see us use it in other ways, including when we go to solve by complete the square.